All right, welcome back to Mechanical Systems Design. So this is a quick video to review the Project 2 description. And I'm pretty excited about this project. I had a lot of fun doing it myself, and I think you're going to have fun with it too. So this is really similar to the first project, but we've changed the scenario a bit and made it a little bit more challenging. So you'll design a component using back-of-the-envelope analysis and finite element analysis and prototyping. You'll fabricate it with your 3D printer, test it, report the test results, and write a written report. But this time, we're really going to dig in to design for mass efficiency. And that's something we'll discuss over the coming week or so. But it will require a little more sophisticated application of free body diagrams, stress analysis, buckling analysis, and all those things in both back-of-the-envelope analysis and finite element analysis, and probably a little more prototype testing for this one. And fortunately, you'll have more time to do that too. So here's the scenario. We're calling this the two towers. You have two chairs set back to back, or any rigid structure, and there's a gap between them. And then in between them is a heavy thing that has a string that comes up, and your component will go somewhere in here, and it will support the heavy thing by that string and by contacting the rigid structure. And here's a close-up view of that diagram. And you can see that the two supports must be exactly 15 centimeters apart. That's from the closest part that your component makes contact with. And your component cannot go beneath this line between the two lowest points of contact. So you can go anywhere up here you like, but you couldn't, say, have an upside down rainbow. That would violate this non-interference region. Something else, we're pretending something else has to go down here, so your part can't. So your part will probably rest on these surfaces. Maybe there's some other interaction there. You have this rope coming up from the heavy thing that will terminate on your component somehow, maybe not, who knows. And the minimum load that your component must be able to take is 100 newtons. One change from the last project is that we will ask you to use a bucket or some other system that allows you to slowly increase the load on your component to find out where it breaks. And then you'll report that. We're going to set a limit of 200 newtons so nobody gets hurt. It's actually hard to find enough heavy stuff that fits in a 5-gallon bucket to get over 200 newtons in a typical household, turns out. Okay, so that's how that's going to work. We'll make them with our 3D printer again, also using PLA. We use the same design process as we used in the first project, except again, we'll use this a little more with a little more advanced steps. And just as in the first project, we will have you test your components at home. You'll record the mass of your part and the mass at which it broke. Remember that you have to ramp that up. And then you'll put those into an online spreadsheet. You'll provide a video of the test and some photographs of some things. This time, we're also asking you to provide your G code so that we can make some of your components and see how they perform and maybe do some videos and analysis. All right. You will once again have a performance-based portion of your grade. Almost the same calculation. It's just that we're increasing the percentage for each of nominal and mass-based to 15% from 10. You will we'll hand out some awards, and you'll provide a report. And the report will be almost the identical format. We just made a few little tweaks along the way. We're going to ask for 400 words now instead of 200 words to describe your component and explain why it's like that. And we've shortened our list of bullet points for that summary page a bit. The simple models and analysis should have a really similar format, and the detailed models and analysis, now we're asking for both stress and buckling. So we're going to dig into all these topics in more detail over the next couple weeks and work with your coaches on formulating your design ideas and your process. It's going to be a lot of fun.